Hi, in this video I'm going to show you how to launch a layer 2 attack that will cause denial of service on this network. And this is very useful in case you are studying for CCIE Security, so it's good to know from the attacker perspective how these layer 2 attacks take place. You can know and understand which technique, which technology to use to prevent those type of attacks from occurring in the first place. So we have a very basic network and it is 192.168.1.0, and we have R3 with the IP.3, PC4 with IP.4, and the attacker with IP.2. The switch doesn't have any IP because we don't need, and we want to see the communication between PC4 and R3 just like it would be a regular network access between two machines on the same network. So if we go to PC4, so you can see that's my IP, and if I try to ping 1.3, I'm successful. Okay, so we don't have any problem whatsoever, so it's running just the way it is supposed to. Now if we go to our attacker and launch the attack, so I'll be using Mac off to launch this attack. And if you go back to PC4, we see that something is strange. We're not receiving any reply back from R3, so it's taking some time. And look at this, we had what, around 10, 12 as a response time, but now we have 9,000, 8,000. And something is happening in the network. And if we try to log into switch 3, or actually switch 1, just to diagnose, you can see that I can't access switch 1, so it's inaccessible, and that's a big problem. So I'm going to pause this attack. So this is a layer 2 attack, and what just happened was MAC address flooding. So essentially the cam table of switch 1 just was full and it wasn't able to handle any more packets. So legitimate traffic from PC4 to R3 wasn't being sent because the switch was just so busy trying to reply or to handle the packets coming from the attacker. And actually let me run this again because I want to show this. I'm sniffing the packets on port 01 of switch 1, and you can see the attacker is launching all these requests, bogus requests, and the switch is trying to handle them. Now it's became unresponsive again. I'm going to pause this attack. So what is happening? So first, before we apply a solution, we have to understand what is the problem, why the switch becomes unavailable, why PC4 is unable to reach R3. So we have to understand what's happening. Now from a basic network perspective, we know that computers or routers, they speak at layer 3 between IP address, and at layer 2 they have the MAC address, right? And whenever PC4 sends a packet to PC3, so it has the information about the IP and the MAC address. Now if we send this packet from PC4 to R3, now this packet will be encapsulated into a layer 2 packet or frame, will be sent to the switch, and then the switch will query, okay, how do I get to the MAC address of R3? So let me bring switch 1 console. So let me show the steps. So if we look at port 02, so that's MAC address of PC4, and we can confirm that. So let's go back, stop this. So we can see that the MAC address, let's see this, filter this, enter. Okay, so PC4 MAC address is, let's see, 5400, and we can see this is the MAC address. So if PC4 wants to talk with R3, then the switch should be able to handle this packet. So he's going to query where is the MAC address of R3. And if we look at the MAC table for port 00, we see we have two MAC address. Now let's confirm which one belongs to R3. Let me bring R3. Okay. And if we look at 00 port, so R3 MAC address is 0200. Now if we go back to switch 1, 0200, so that's the MAC address of R3. Now based on this information, PC4 and R3 are able to communicate, because PC4 knows the MAC address of R3. So at layer 2, the switch knows how to handle this, and at layer 3, PC and routers, they know how to handle this as well. Now, when we send a packet destined to an IP that the switch doesn't know what's the MAC address assigned to that IP, so the switch is going to float a broadcast to all the other ports except the one where that packet was received, until someone replies saying, look, this is my MAC address, I'm connected at this port. Okay, and that's what essentially what is happening. If we look at the MAC address table for, let's see, port 01, we can see that we have a lot of MAC address entries. Okay, so essentially the switch is trying to know okay, between these packets that the attacker is launching, what is the corresponding MAC address associated to one of its ports. And because it's trying to figure out, so its CAM table, that's where the MAC address are stored, just got full. So that's the problem, because we have a lot of MAC address. We have more MAC address on the switch CAM table that it can handle. Now the question is, how do we solve, or how do we prevent this problem from taking place? We can use a feature called port security. So port security allows us to restrict the number of MAC addresses that can appear on a port. What I mean by that, so if we recall, let's go back, for instance, for port 00, we only have two MAC addresses, but if we look at, let's see, 02, we only have PC4 MAC address. And we can apply port security to say that if two MAC addresses appear on this port, we want to shut down this port. We want something to happen, but we don't want to allow more than one, more than two, more than three MAC addresses to appear in this port, and we can set this limit. Okay, so that's how we can prevent this type of MAC address flooding attack. So let's do this on port 01 of switch 1. So we go to port mode, and first we have to make this port an access mode, and we're going to enable switch port security. First we have to enable port security on this port, and let's say that we want to use port security and the max. So if we look at the option, the maximum number of MAC address, we're going to limit to only one. Okay, and we can also say that if a violation, so if this number exceeds, we want to do something. If I don't do this, it will take a specific action. There is a default action. So let's see, do show port security on port 01. So by default, the violation mode is to shut down the port. Okay, I can leave it as it is. I can also explicitly say, you know what, if something happens, I want to shut down, or I want to protect, or I want to restrict, meaning don't shut down, just drop the packet silently. So I can choose one of these options, and I can also say the MAC address on this port, I want it to be stored in case the switch is rebooted. So just going to leave as default, and let's try to launch the attack again from the attacker. And let's see, so let's run the ping first from PC4, to R3. Okay, let me send packet again, and let's launch the attack once again. Okay, so the attacker is running, and look, now PC4 still receiving replies from R3. Now if we go back to switch 1, we see this log saying that port 01 is shut down. What's the problem? Okay, if we look at port 01, it says that its line protocol is down, but it's error disabled, so something occurred in this port. And if we look at port security for this port, so do show actually that's do show port security for this port. So port status now is secure shutdown, so a violation occurred, and that's how we can prevent MAC address flooding from happening on the network. Now, in case we want to apply this feature on, let's say, PC4 as a legitimate user, you have to be cautious about using, otherwise we can cause problems on the network. For instance, if we enable on port 02, let's say port security, so first I have to make this an access port, so switch port mode access, switch port security, and let's say switch port security max, actually not max, but I want to say sticky. Okay, actually what is it? So MAC address, yeah, sticky. Now what I just did is this MAC address, so PC4 MAC address can't appear on another port. Okay, so if let's see 02, so now this MAC address can only appear in this port. If it appear on a different port, we will have a problem. Let me show you what I mean by that. So we have ICMP still running. Okay, so I'm just going to disconnect this. So we're using 02, let's use 03, and we receive a message. So now ICMP is failing, so let's give some seconds to see if the port is going to negotiate. Okay, but it looks like still down. Okay, and let's see what's happening. What is the problem? To show MAC address, let's see 02. So I have PC4 MAC address on port 02. What about 03? Now I have this MAC address on port 03. I don't know what MAC address this belongs to. Oh, so if I close this, let's see if config, do I have this? No, I don't have this MAC address. Okay, but the thing is, now PC4 can't access the network because the switch knows that that specific MAC address is already on port 02. So although this is a very useful feature to use, but just before deploying on the network, do some homework to understand how it works, and also in which ports or use case it is really required to be deployed. You don't want to get calls from your colleagues complaining that they can't access network because you just enabled port security on one port, and now they can't access the network because the MAC address is sticky on a different port. So that's it, guys, how to perform MAC address flooding and how to prevent it. I hope you guys enjoyed, and I'll see you in the next one.